What's up guys, and welcome back to another video. So this is going to be my first ever thermal repaste. And why am I doing this? So recently my computer has been running into a whole lot of issues from like about last year November, and what's been happening is that it's been overheating a lot. I've been dropping a whole load of frames on all sorts of games, but then each time I check, it's not even the GPU that's been bottlenecking, it's always the CPU that's losing clock speeds. So today I'm about to get into what's going on with this laptop, and I'll be trying to solve it. So right now I'm running an online benchmarking tool. Right here, this is called Silverbench, and this is basically an online benchmarking tool. So it runs entirely on JavaScript, and you can use it to benchmark or stress test your computer, and you can upload your scores onto a leaderboard like this. So moving on, and now this is hardware info, HW info 64, and this is what I'm using as my temperature monitor. So what's basically happening here is that right now I'm doing a stress test just to warm things up and get it settled. What I'll be doing is that I'll be seeing what sort of temperatures that this goes to when I run the benchmark on this, not the stress test, the benchmark. So already the maximum temperature has gone to like 86 degrees Celsius on this run of the stress test, and I'll be seeing what's going to happen later onwards. So normally when I have this window open when I'm gaming, each time on Valorant for example, it's a very CPU intensive game, it would always start overheating, and you will see this set of numbers, and this will start to go red, and they will be on about 90 plus degrees Celsius. And 90 plus degrees Celsius is very close to your throttling temperature. So if you go here, this says core temperatures, core distance to TJ max, and CPU package. So the temperatures you want to look out for is this one, the second one, core distance to TJ max, and CPU package. CPU package shows the overall temperature of the entire CPU. This one shows per core, you can expand this. And core distance to TJ max means how far is it from the thermal throttling limit. So right now we're about 31 degrees Celsius away from it, but then going on as this computer heats up, you will see that this temperature will change. So right now the stress test is really pulling this down, and we're at 1.82 gigahertz. Normally this is at 3.4 gigahertz on maximum boost, and the average is at 1.1 gigahertz. So I'm gonna go back and run a benchmark. So if I run a benchmark, you will see all of these goes to 100, the utilization, and the core utility, the actual utility, goes to about 120%. And this temperature, you would see this rising, and see this is at 2.2 gigahertz, and this maximum temperature, this was about as it was earlier. You should see this rising ideally. And see, this temperature is really closing in now, 28, 29, earlier it was in the 30s. So I'll be running this test over and over again, and until I get to somewhere even close to thermal throttling. This is the first run of Silverbench, and I got 9723. I'll be running it again to see what our second run is like, and I'll get you posted again. Now as you can see, on this run things were different, and although this says 72 right now, that was as soon as the clock started slowing down. This one says 92 degrees Celsius, that's the maximum core temperature, and the CPU package, the overall package, of the entire die has gone up to 91 degrees Celsius. Now that was way more than earlier, the temperature we had earlier. So now we are very close to thermal throttling, and the smallest gap to the thermal throttling threshold has been 8 degrees Celsius. So as we run this benchmark again and again, we'll be able to see a very different lots of decrements in this value of the distance to TJ max. And as we are getting close to the end of the second test, 9728, very close to the first test, but we will run it again. Now see what happens when I will minimize. I'll get this smaller. Now see what happens as soon as I press run again on this temperature. Right now we are on 63, 68, all 60s. I'll reset this, and these are all on 60 degrees Celsius. Fair enough. And as soon as we hit run again, see what happens. 71, 72, and all of a sudden 80s, 90 degrees Celsius, 92. And this CPU package, the maximum temperature recorded, jumped all the way till 93. That was all while this clock was still running really fast. As soon as it senses that this temperature is getting very close to the thermal throttling limit, it slows down this clock to keep things stable. So we'll wait until the end of this run, and now we are close to the ending of this run, and we'll see what the score is like. 9665. So today is a really cold day, to be honest. It feels like 26 degrees Celsius outside here, and that's probably why none of these mentioned even thermal throttling anywhere here. But trust me, on other days it just goes red, like legit red. So moving on, what I'll be doing is taking this apart, and I'll be inspecting what the thermal paste, the condition of the thermal paste inside this is going to look like. So the reason why I'm doing this is I've searched on Google what's the issue with the same symptoms on the laptop, and a lot of them have taken it apart and the thermal paste was all ruined and dried up, which is a completely normal situation. But the thermal paste is something that requires replacement over a couple of years, and given that this is already 4 years and it's been put through heavy loads every day, which goes from the heaviest load being music production really, and I'll be taking this apart and I'll be trying to see what's going on. Now this bit is precisely what I mentioned earlier. Now look at all those red numbers under the maximum section, the one that says maximum, the column there. So those numbers are representing the numbers that are showing all the throttling, and that's well below 90 degrees Celsius, very close to 100 degrees Celsius, and that shows us clearly that we are thermal throttling. And under the core thermal throttling tab it says yes. Now this right here is me frantically trying to figure out how to remove this thing. I watched a few YouTube videos about a laptop similar to this chassis, but then I couldn't find the exact same model. Also reason of making this video, but then I eventually did figure this out, and here is me trying to take it off. First of all, you should take off the CD drive before taking any of the other screws off, because the CD drive also has something to bear the load on the entire chassis. And there's another lid right, which houses the hard disk and the RAM slots and the M.2 slot, and that has to be removed before the entire back casing as well, because there are still more screws inside that area. And yep, right here I'm hiding it. Really hard to remove it because of that entire storage compartment, that entire part containing the RAM, hard disk and the M.2 slot. So there you go, that was that slot, and those are the internals. And now I'm able to remove the entire backplate, and off comes the entire thing. I may have broken a few pins that are holding the backplate onto the chassis, but overall it just came out really quite swiftly. The entire cooling system is done by one single heat pipe, which is shared between the GPU and the CPU. So imagine your CPU starts thermal throttling at about 90 something degrees Celsius, and that will heat up your GPU as well. So that was quite the drawback of the design on this system, but it is what it is. Now this is the internals after taking out the cooling system, and already you can see the thermal paste attached onto the cooling system and the dies. And this thermal paste, as you can see right here, is really hard and stiff. It's almost like some sort of cement, and that right there is a part of the problem why this was overheating so much. So now we are going to replace the entire thermal paste. And now this is the die, the CPU die on the right and the integrated graphics die on the left, and that is the NVIDIA discrete GPU. So already I've completely cleaned it off from thermal paste, and it's pretty shiny. This right here is the representation of how much dust this thing was collecting. Now look at the fins on the top. That's where all the air gets received from the right side. And man, there was so much dust on this entire thing. So what I did was I took an old toothbrush and I just brushed it right off. Did the job. This right here is the cooling system on the heat pipe, and on the left the aluminium block is for the CPU and the copper block is for the GPU. Now I cleaned it off as well, but it really surprised me how thin this entire system was. Like, this was just sheet aluminium and sheet copper that's trying to cool down this entire thing. I'm not entirely sure if that's the bottleneck of why the system runs this hot, even regardless of like factory thermal paste, but still it's pretty thin. Is pasting the thermal paste onto the board and screwing the entire thing down. Small blob for the GPU and the discrete graphics, and the larger line for the CPU. And on the nails, on the terminals, they have given numbers, and those numbers are the order that you have to screw them down. And when unscrewing them, you're supposed to unscrew them in the descending order of those numbers. And here is the finished product. All good, and nothing's leaking anywhere. Put just about the right amount of thermal paste, and we are good to close the back cover. So here we go. And now that this project is almost done, I'll be running a few benchmarks on the same benchmarking tool, Zero Bench, and showing you what sort of temperatures this is going to show. So anyways, this project has been pretty eye-opening for me, because to start off with, I've never opened the back of a laptop before, to be honest. Like, maybe just for a few cleaning tasks, but nothing of this sort really. So it was quite a fun project of taking everything apart and putting it together successfully, and I really do hope the results do show well in terms of temperature and performance. But yeah, pretty fun project for a cheap price. Now here we are after applying the thermal paste, and I reassembled everything, and already our idle temperatures have dropped way below, and already we are on the borderline of 40 degrees to 50 degrees Celsius, and that is a huge improvement from last time. Earlier we were almost at 60 degrees, we were 60 plus degrees Celsius, and the minimum has been recorded here as 41 degrees Celsius, and that's a major improvement already. So we'll run the benchmark and see what happens. Another thing I noticed is that this laptop has gone a lot quieter than it used to be because of the cooling now. And anyways, we will get to the results once this run has been over. And as we are getting to the end of the first run, already our temperature has reached only about 69 degrees Celsius. Nice. And the maximum has gone to about 87 degrees Celsius. So let's just read this number. This is the important number, 70. And see, look at this is a huge jump from what we had last time. So early it was some 9,000 something, the 9,000 range, and already we made a jump of 1,000 points. Amazing on this. So once again, we will read on the test, and I'll keep you posted about what happens. This is the end of run 2, and we will see the test results. 9,857, almost 10,000, and we managed to get these are the maximum temperatures, and even throughout the tests it was hanging around the 70 degrees Celsius mark. I'll read on. So closer to the end of test number 3, and we are still hanging around the 70 degrees Celsius mark, although a tiny bit hotter on this run, and a score of 10,468. All these 3 scores have been higher than the earlier 3 scores, and I think it's done a pretty good job in cooling it down. And also through all these 3 tests, you might have seen the core clocks, and they clocked a tiny bit higher than what would have been the non-repasted cores. So I think this had been a pretty good success, and I'll be benchmarking this on Valorant as well, just a few death matches. And early on Valorant, I did play Valorant on this earlier on the day after the repaste, and I gained about 10 FPS. Used to be 16, completely terrible, but then now it's about playable, under 30 FPS. But then still the major bottleneck is the CPU. This GPU is at about 50% usage, but on CPU heavy games like that, it just bottlenecks right there itself. So anyways, till I get a new one, this one should survive.